In the subject of electrical circuits 2, which are broken out into AC circuits and three-phase systems in electronics, you'll find in the manual a chapter by the name of AC circuits and a chapter called three-phase systems in electronics. In the NCEES handbook, you'll find the AC circuits on pages 68 and 69. The electronics is on page 68, and the three-phase systems is on page 95. For a sinusoidal voltage, it's described by V of t is equal to V max times the sine of omega t plus phi. To view all these, let's sketch a sine wave. This is t equals 0. The maximum value that the sine or the cosine achieves is V max. The angle of displacement with respect to the t equals 0 axis is the phase shift phi. The time it takes from when the signal starts a cycle to where it ends the cycle over here, this is a period. The frequency is equal to 1 over the period. The angular frequency, omega, is 2 pi times f, which is 2 pi divided by t. So omega in this equation is 2 pi over the period. Phi we know is the phase angle, and V max is equal to the maximum value, which in magnitude is the same as the minimum value if there's no DC level in the signal for a pure sinusoid. So reviewing these symbols will be very helpful to us in what we plan to do on subsequent discussions. This represents the trigonometric form of the sinusoidal waveform, and it is very useful depending on the type of analysis you're doing. But frequently we find that the phasor description is also very helpful. And the phasor description, we usually specify a magnitude and an angle for a voltage. Now imagine that time were standing still, and if it were, the voltage can be shown to be a complex number that has a real part and an imaginary part, and it forms some angle with respect to the reference axis. And notice that if we let the clock start to run now, and this vector continues to move, as it will move in a counterclockwise direction like this, as it does that, the projection onto the real axis will shrink and go to 0. It will go negative on this side. It'll get large. Then it'll start to shrink again. And so we see that the projection onto the horizontal axis or onto the vertical axis will give you a sine or a cosine behavior. And so the phasor representation will simply be shown in many situations to be simply a magnitude with an angle, and if we let time stand still, we can do a very simple analysis of the problem.